Hi friends, welcome back once again with a new topic. Today in this lesson we are going to deal with the circular motion of a car. Okay, circular motion of a car. The circular motion of a car, here itself we are discussing two cases. What is the first case? The car is moving on a circular track but the road is a leveled road. Okay, the road is a leveled road. Next case we'll be dealing with the car on a banked roads. The car on a banked roads. So these are the two cases we are going to discuss in this lesson. So let's discuss about the first case. The car is moving on a circular level road. Okay. So just before that, just to consider a circular motion. So as you already learned, whenever a body is moving in a circular motion, there is a force which is acting towards the center, and that force is called what? Centripetal force. And the centripetal force formula you have already learned. F is equal to what? mv square divided by r. mv square divided by r. Now you just think about, this is a circular road or just like a turning, okay? Just a turning. Car is now negotiating the curve. Car is now negotiating the curve and the road is a leveled road. So just let me draw here one car shape here. Okay. So this is an example for car. Car is now moving in this direction. Okay. The car is moving in this direction. So when the car is now negotiating the curve, which all forces will be acting on the car? That is the first one we are discussing about, which all forces will be acting on the car. First case, if you consider this is the center of gravity, okay, there is a force which is acting vertically downward, that is on the road, that is equal to mg. So as you already learned, according to Newton's third law, there will be equal and opposite force will be acting, right? And that is called what? Normal reaction force. Here the normal reaction force will be acting on the body, right? So this side there will be two tires. This is the normal reaction force, say it as R1. And this side also there will be two tires. On the two tires there once again there will be normal reaction force will be the, and say it as here R2. So what is the total normal reaction force will be acting on the car here? That we can mark here. What is that? That is the R1 plus R2. R1 plus R2. Here the magnitude of lines are not to scale, okay? So opposite of mg, which one is acting here? Normal reaction force, which is acting on the four tires. This side two tires and this side two tires. So total is equal to what? R1 and R2. So total will be equal to what? R1 plus R2. Now next question is here what? Definitely this is now negotiating the curve, right? So definitely there must be a centripetal force acting towards the center. If that centripetal force is not present, what may happen? The car may move tangentially. The necessary centripetal force towards the center of this curve is provided by the frictional force acting between the tires and the road. When the car is now negotiating the curve, you can see here this side two tires provides a necessary frictional force which will be acting in this direction. Say it as F1 is the total frictional force by these two tires. Same way the other two tires providing a frictional force in this direction. Say it as here F2. The necessary centripetal force provided by these frictional force. So here what is the total frictional force? Total frictional force is equal to F1 plus F2. F1 plus F2. And you already learned in the last lesson what is the frictional force formula. Friction force F is equal to mu into normal reaction force. That is, we can write this equation as, what is the total friction? F1 plus F2, which is equal to mu into normal reaction force. What is the normal reaction force here? That is equal to R1 plus R2, the total normal reaction force. That is equal to which one? mg. R1 plus R2 is equal to mg. So we can write here F1 plus F2 same as what? F, which is equal to mu into mg. Mu into mg. So this is the frictional force which provides what? Necessary centripetal force. So when the car is now negotiating this curve, the frictional force must be greater than or equal to the centripetal force. So here the F1 plus F2 same as F, the frictional force must be greater than or equal to the necessary centripetal force. Okay, now you can write here what is F here. F is equal to mu mg, right? So we can write here what mu mg must be greater than or equal to the necessary centripetal force. So what is the centripetal force formula? Here we can write here what mv square divided by r. So the frictional force in between these tires and the road must be greater than or equal to what? The necessary centripetal force for negotiating this curve. So here mu mg is equal to mv square by r. Here mass of the car is m, that will cancels here. So we can write here mu g must be greater than or equal to v square divided by r. Or we can write here v square divided by r is less than or equal to mu g, right? Or we can write v square is less than or equal to mu into rg. So we can write here V max, the maximum velocity with which the car can move without an accident, that is V max is equal to, right, square root of mu into rg, square root of mu rg. That means if the car or any vehicle exceeds this limit, the speed limit, what may happen? The car may skid and it go off the road, maybe tangentially. Okay, so you may be seeing some curved road, or maybe in the hairpin, the speed limit is written on the board. What is the speed limit here represents what? If the car or any vehicle is moving more than that speed, it may cause what? An accident. So this is the maximum velocity formula for which the car can move or negotiate the curve without any accident. Hope it is clear. Now let's discuss about the circular motion of a car on a banked roads. So first of all, what is meant by banked roads? You may be seen somewhere in the road, especially in the turning and all. The outer edge of the road is raised a little bit comparatively the inner edge. Is actually called what? Banking of roads. What is the definition of banking of roads? The system of raising the outer edge of the road, that is the outer edge of the curved roads above its inner edge, above its inner edge, that is called what? Banking of roads. If so, what is meant by angle of banking? The angle through which the outer edge is raised above the inner edge, and that is called what? Angle of banking. What is that? Angle of banking. Now let's discuss about in detail what is the banking of road or the banked curve. Okay, consider a curved road here. Okay, again you consider a curved road. Okay, a curved road. But what is the peculiarity of this curved road? This is not a level road. This is not a level road. Here the outer edge of the road is raised above the inner edge. You see, this is the inner edge and this is the outer edge. The outer edge of the road is now raised a little bit. So just imagine a car, okay, a car is now moving on a banked road. Which all forces will be acting on the body? First case you have to consider here, which all forces will be acting on this body. So as you already know, if this is the center of gravity, you can see here the force which acting on the body, that is the mg is the first one. Is that mg is the first force. And as you already know, there will be a normal reaction force will be acting exactly normal to the surface. Okay, exactly normal to the surface. Which one will be acting here? The normal reaction force will be acting R. Now here also the car is now negotiating the curve. Only the difference between the level road is that here the road outer edge is slightly raised. Okay, that is called what? Banking of roads. And this angle is called what? Angle of banking. Now definitely this is also moving in a circular motion, so a centripetal force must be provided. Here the R or the normal reaction force can be resolved into two components. You can see here it is resolved into two components. If you resolve these components, what are the components will come here? If this is the angle theta, right, this angle also become theta. If this angle become theta, this angle also become theta. So what is the component of r along vertical direction? We can say here that is the r cos theta. R cos theta. Next one, so what is the next component acting in this direction, right? The next component will be acting in this direction. What is that? If this is a cos theta, this component become what? R sin theta. So we have resolved this normal reaction force into two components, r cos theta, and here become what? R sin theta. Here r sin theta provides what? The centripetal force. Okay. Not only r sin theta, one more component will be acting here. That is the frictional force. That is the frictional force. See, what is the friction direction in this case? The friction direction means the friction will be acting in between the tires and the road, right? So friction will be acting in this direction. Say it as this is the effective friction. Here, say it as this is the friction F. Here also friction can be resolved into two components. See this one? Friction also can be resolved into two components. If this is the angle theta, what is the angle this one? That angle also become what? Theta. So we can consider this angle also become theta. So the frictional force F can be resolved into, again, this is F cos theta, correct? And what is this component? Downward component, that is what? F sin theta. So frictional force also can be resolved into two components, F cos theta and F sin theta. So now you can see here who all are providing the necessary centripetal force to negotiate the curve. You can see the r sin theta component as well as F cos theta component provide the necessary centripetal force. Now equate the forces along horizontal direction as well as the vertical direction. So the first case here, who is providing the necessary centripetal force? You can say here, first one is r sin theta plus, what is the next one? That is F cos theta. R sin theta plus F cos theta provides necessary centripetal force. We can write here mv square divided by r, equation number 1. Correct? That is a horizontal direction force. Now if you consider the vertical direction, okay, what is the vertical direction here? R cos theta and mg here vertically upward and downward, and here also F sin theta vertically downward. So if you equate the vertical direction forces, we can write here that is mg is acting vertically downward plus, what is next one is acting vertically downward? That is the F sin theta. What is that? F sin theta, which is equal to upward force. What is upward force here? That is equal to r cos theta, equation number 2. R cos theta, we can rearrange this equation as r cos theta minus F sin theta is equal to mg. So the equation number 2, we can write here side as equation number 3. Now what you have to do here? Equation number 1 divided by equation number 3. Okay, equation number 1 divided by 3. What you are getting now here? R sin theta plus F cos theta is equal to mv square divided by r all divided by, okay, all divided by r cos theta, what is next one? Minus F sin theta divided by, here what become mg. Okay. So equation number 1 divided by equation number 3. R sin theta plus F cos theta, which is equal to mv square by r. R cos theta minus F sin theta is equal to what? mg. Okay. Now if you cancel this one here, we can see m will cancel. Now what you have to do here? Divide this left hand side of this equation by r cos theta. if you divide the entire term on the left hand side with the r cos theta, you see this one, r sin theta divided by r cos theta, what will become? R cancel and it become what? Tan theta. Okay, plus once again f cos theta divided by r cos theta, here it become what? F divided by r all divided by r cos theta divided by r cos theta, that is equal to 1 minus f sin theta divided by r cos theta, that become, we can write here, f by r tan theta, which is equal to, you see this one, m cancel, so we can write here about v square divided by rg, v square divided by rg. Now you see in this equation, what is f by r? F by r is equal to mu, correct? Friction is equal to mu r, so we can write here f by r is equal to what? Mu. Mu means here static friction, the mu is. So we can write this equation as tan theta plus mu. Okay, I am not writing mu is here, writing only mu. Mu means what? The coefficient of friction. Here it is static friction. So tan theta plus mu divided by 1 minus mu tan theta, which is equal to v square divided by rg. V square divided by rg. If so, what is the velocity equation? What is the velocity equation? We can write it as v square is equal to, okay, just rearrange this equation, v square is equal to rg into, okay, rg into mu plus tan theta, rg into mu plus tan theta divided by 1 minus mu tan theta, 1 minus mu tan theta. Therefore, what is the velocity is equal to square root of rg into, okay, square root of rg into mu plus tan theta, mu plus tan theta divided by 1 minus mu tan theta, 1 minus mu tan theta. So here what we represents here, the speed with which the car is negotiating the curve on a banked road. Now you just imagine, there is no friction is acting between this road and the tires. Just imagine there is no friction, okay. So in that case, if there is no friction, we can say that the coefficient of friction is equal to what? 0. So we can write during that case, the speed is equal to, this one, rg into, see, mu is 0, right? This mu is also 0. So here what will happen, the tan theta by 1. So we can write here rg tan theta. So this is the relation when there is no friction acting between the tires and the road, the speed is equal to what? Root of rg tan theta. So from this equation we can also calculate the angle of banking for the minimum wear and tear. Minimum wear and tear. So what is the formula here? Tan theta is equal to, okay, tan theta is equal to v square divided by rg. Tan theta is equal to v square by rg, or we can say that theta is equal to tan inverse of v square divided by rg. So this is the way to calculate what? The minimum angle or the angle of banking for minimum wear and tear. Okay, minimum wear and tear. So in this case, if you compare with the leveled road and the banking of road, okay, where the friction will be acting more for providing the centripetal force in the first case. Because the necessary centripetal force is not provided by the friction alone, there will be one more component is there, what? R sin theta. So in the banking of roads, in the banked roads, the wear and tear will be minimum, and that angle of banking can be calculated here, what? Theta is equal to tan inverse of v square divided by rg. Okay, I hope it is clear. So we have discussed two cases here. On the leveled road and on the banked roads, the car is now moving or negotiating the curve. Okay, hope you understood this topic. Thank you all of you.